Hello. In front of me I have a Wurlitzer 7300 combo organ from the late 1960s. Little quick piece of history if you do not know about combo organs. They are a kind of electric keyboard instrument that was popular in the mid 20th century, but it's interesting and important as a piece of history because it is the predecessor to everyone's favorite modern keyboard instrument, the synthesizer. Just like a synthesizer, a combo organ uses oscillators to produce tones that you can trigger with a keyboard. Of course, you get less control over the sound that you get out of a combo organ, but they, I personally think, are cool in their own way and have their own kind of sound that you can't really get out of a synthesizer. They're very simple conceptually. You have, basically 12 oscillators, one for each note in an octave, and the way that we get every note on the keyboard and the way that we get it to sound like an organ, because something about organs is that they're very harmonically rich in the tones that they produce. When you play a note, or especially a chord on an organ, as opposed to another keyboard instrument like a piano, which has less harmonic information for the most part, not knocking pianos, they're great, but organs are different. And in order to kind of mimic that, you have, lower notes containing lots of higher harmonic information, basically. And the way that pretty much every combo organ achieves this, well, I think yet to find one that doesn't do this. That's why it's called a combo organ, actually. The way that it's done is that you have an oscillator board, like I said, 12 oscillators, one for each note, and the oscillator primarily produces all 12 notes in the highest octave. So you get that, and then for each lower octave, there's a number of circuits. They're all pretty much identical or very similar, where that voltage, that waveform, is divided. It's halved and halved and halved and halved until you've completed the range of the instrument. I think that's what I've heard about how these work. I'm not an expert. I'm a student, very relatively new to electronics. I've only been participating in electronics for a couple of years, but I like to think that I'm thorough, and from my research, that's what I've gathered. And something that, pretty much the main problem with this organ is that you only get the highest notes. They're a little bit out of tune. But in order to deal with that problem, you got to deal with the primary issue, which is the fact that it seems that none of the dividers are dividing. And so you're not getting really any harmonic information lower than the highest octave, lower than the primary waveform, the primary highest tone for each note. So, I think every key triggers some kind of sound. And it's not just pure noise. There's an amount of tonality to it, and for the most part it sounds in tune, like relatively in tune. But that's the problem that we have. And my main purpose and goal for making this video and the videos that will come after it is to document this instrument and document my repair in case anyone wants to fix one in the future. There's a website online, really amazing resource that I have been using I'll link to it below, but I think it's just Wurlitzer7300organ.com or Wurlitzer7300.com. It's where I got the service manuals, where I got the schematics that I've been referencing. Incredibly crucial to being able to do this work, especially for someone like me who has never worked on a combo organ before in my life. Indispensable resource. But beyond that, there's not a lot out there. There's not a lot out there about this, and it's a very, very, very special and cool and rare organ. It's a piece of history. It's Wurlitzer's only organ. Hey, the Wurlitzer 7300 was not Wurlitzer's only organ. That was incredibly wrong. It was one of only a couple of combo organs that they made, but they made lots of other organs, theater organs, player pianos. Anyway, Wurlitzer, if you do not know about Wurlitzer, they were mainly a jukebox manufacturer, if I have that correct, but they were also very famous for their electric pianos. You see them still a lot. I'd say that they are synonymous with electric pianos. Well, Wurlitzer and Rhodes. Those are the two big names in electric pianos that I see. Personally, I prefer the Rhodes electric pianos over the Wurlitzer ones, but like in how they sound. I don't have any of them, but this is a cool organ, and it's tiny for what it is. It's like kind of remarkable that they were able to squeeze all of this into such a small package in 1968. A cooler part about it, one of my favorite parts about it, as comparing it to other organs of its time, is that it's actually packed full of ICs, which is really cool, and all of the semiconductors are silicon. You usually run into a lot of germanium transistors in, for instance, like a Farfisa mini compact. Farfisas are packed with germanium transistors, and germanium transistors can be, from what I've read and gathered, can be a leading cause of grief with Farfisa organs and other combo organs, because of the physical properties of germanium. It degrades over time, and that leads to elements of the transistor also degrading. Not the best description, but basically, if you know anything about transistors, the beta, or the current gain, essentially, that's the beta, the base 2 emitter current gain, I think. I just learned what transistors were like a few months ago, so forgive me if I got beta wrong. But germanium transistors decay, and the beta over time decreases due to the physical deterioration of the germanium and of the PN junctions within the transistor. So that's a problem a lot, and I thought that was my problem. I think I thought that was it, but I think that it's not anymore. I'm not so convinced. It would have been a convenient problem to have, but I'm kind of glad that it might not be an issue anymore, because having to replace a bunch of transistors would have been really annoying. And I've already replaced a lot of stuff in here, which I will talk about shortly once I stop running my mouth about how cool combo organs are. There's a lot to catch up on. I've had this thing for multiple years and thought multiple times about documenting the work I've been doing. And now, when I'm really feeling ready to just get into this thing, now is the time that I let it all out. What was I even talking about? I don't know anymore. something about germanium, something about transistors, something about something. Anyway, I don't want to have to replace all the transistors in the tone generators. That would not be very fun. I'm hoping that I won't have to, because I was poking around with my voltmeter today and I found that a certain voltage, certain supply voltage, DC supply voltage, from the high voltage power supply. It comes from the high voltage power supply. It's not really a high volt. It's like 3.45 volts. But it comes from the high voltage power supply stage. The power supply has two stages. It was reading like significantly below where it should have been. And I traced it back, and long story short, ha ha ha, that's a good one. There is a bad power transistor. In fact, one of the first transistors that you see, it's the biggest transistor in the whole organ, is open circuited, from what I can tell. It is the base and the collector are not taking any current, and that's not what should be happening. So I have a replacement for that coming, as well as replacements for like pretty much every other transistor in here, just because even if I don't have to replace them right now, who knows what's going to happen once I get this thing working and start using it. I want to be prepared. I don't want to have to put it down and come back to it, and put it down and come back to it, because I don't have a lot of space. This is like, I got a nice sized room, but this is just sitting on my bed right now, and I want to go to sleep tonight. But anyway, I think that is enough of that. I think I'm gonna round up right now with just kind of showing you inside the organ, showing you what I've already done, and talking about what's next. Yeah, I think that's, yeah. Okay, got the organ open right now. Lifted up the control panel. It's your power switch right there. That's your pilot bulb. Lets you know it's on. I don't have it plugged in right now. I'm not going to have it plugged in for this video, but it powers on, believe me. First thing I did when I got this thing was rebuild the entire power supply. I did the rectifier circuits, and this is the underside of the power transistor I was talking about. Here it is. Took it out. Kind of looks like the Motorola ones that you see, and I wonder, because Motorola bought Wurlitzer, and I wonder if they took this technology. It could also be, I don't know exactly when they bought Wurlitzer, but something to think about for me. I'm sure some of you know all about it. Anyway, that plugs in just below the transformer. You can see the outline. This thing definitely got nice and damp. I've done a lot of deoxidizing and it's still pretty nasty, but turns on. Transformer's fine. I redid the socket, made it a D because it was just a 2-prong before, and although in hindsight that might have been nice because it could have potentially made it noisier, which for something like this is in my line of work desirable. I wanted something that was gonna like not kill me when I was working on it. So you make sacrifices when you buy things that don't work. Anyway, this thing was crazy. I really wish I had taken videos of it when I first got it and like documented the rebuild of the power supply. But when I bought this thing, there was like an enormous air conditioning capacitor that someone had like jammed in here with electrical tape and like parts of a pool noodle. It was beautiful, honestly. Actually, it was this 10,000 microfarad, 100,000, big sucker, right there. It was that one. I love it. I loved it. I don't have it anymore. I didn't love it enough to keep it, but this was in the original a capacitor that had two sections. Sure, there's a name for it. It escapes me right now. Okay, so my phone died on me. Anyway, I think I was just talking about the power supply and the filter caps. Couldn't find a double. Oh my god. I'm filming on an iPad and I just like reached in and thought my hand was. That was. Okay. Gotta get used to this. The perspective is very strange. Anyway, it's kind of goofy. I pulled this one up, but they're just on strip board, and I. Okay. Yep. Jeez. They're just on strip board, and I hot glued it, and that works right now. I think eventually I might come up with a better solution. All right. Anyway, yeah, I think I talked about it already. Rectifier. That's the bad power transistor. Moving on over here, we've got parts of. Actually, one of the other transistors, the other transistor that's a part of the high power supply, which is what this transistor, or the high power, the high voltage stage of the power supply, is this guy that I pulled out right there. The other transistor in that section of the circuit, power supply circuit, is on this board. I don't remember exactly where. And the low power, the low voltage power supply is here as well. And the filter, I believe the filter board, the filter circuit, I mean, you've got your controls here, but I think the guts of it is over here. And then over here is the tone generators like I was talking about. Sorry, I'm kind of falling asleep. Like I was saying, look at those. Look at those ICs, those gold-plated ICs. Really cool. Got a W on them. See if... Or no. Suspicion confirmed. I think these are Motorola. I think maybe this was around the time that they got together. That looks like a Motorola logo. Is it a Motorola? Yeah, I mean, if it's oriented in the direction of the text, that's an M. That's not a W. Well, it's the devil's in the details. Anyway, each tone generator circuit, I mean, they're all physically identical, right? You've got the same thing going on in each. Pretty much, yeah, they're all the same transistors. I can't remember if the rest of it's the same. I think there's a little bit of variation in terms of like resistor values and capacitor values in there. Only a couple capacitors in each. Oh, no, that's not true. Anyway, these are the tone generators. this is where I was suspicious that there was an issue with the transistors, but again, these are silicone transistors, so my whole theory about theory is a strong word. My whole hypothesis about it being a case of, decaying germanium transistors, it kind of, I have less faith in it now. So let me see if I can find it. I believe it's this orange wire right here. The voltage along this orange wire comes from the high voltage section of the power supply, and it should, I think, be about 3.45 volts, and it's sitting around like 1.7, I want to say. The other supply voltages are actually running a little bit high, and honestly a little bit higher than I'm comfortable with. I don't know if that's a factor of, for instance, like the supply on the AC supply on the schematic is said to be 117, and mine is a little bit more than that. It usually runs around 120, 121. So maybe it's a factor of that. But I also noticed that the voltages after the DC voltages after each rectifier stage are at, what did they say? What did they measure? I mean, whatever they measured at, what they measured at was like roughly 1.4 volts higher than what was listed on the schematic, which led me to wonder if, like, did I get some funky diodes that, like, don't have a voltage drop, like a 0.7 volt drop across them? Did I get ideal diodes? And I don't know. I mean, again, I'm honestly a novice to a lot of this stuff, and I put my voltmeter on them, and I measured with it plugged in to the wall, I measured 0 volts dropping across all 4 diodes. And I looked at the schematic, and the only thing that I gathered was that this diode is rated for like really high voltage. It's rated for like 400 volts. And I wonder if, because of like how low we are within its tolerance, does that result in like such a nominal voltage drop across them, and then give us higher voltages out of the supply? I'm not sure. That's kind of what it seems like, but I gotta do some diode review to be sure. Anyway, I'm more concerned about the voltage that is lower than it should be, because that one was connected to the power transistor. That's kind of what led me to figure out that there was no current draw at the collector or the base, and thus couldn't be any current at the emitter, leaving the transistor. And so whatever the circuit was expecting, it was lacking a lot of. And I was also noticing there was like a crazy amount of heat being dissipated. There's a resistor that like circumvents the connection to the base and the collector and just goes straight to the other side, almost like it's like a feedback resistor, I guess. But it was taking, it must have been dissipating so much more power than it was supposed to be, because it was so hot. Like I could feel it. It felt like I had a space heater in front of my face, and I was genuinely worried. And then I think when I found that transistor wasn't passing any current, I realized that, I mean, it had to be that this feedback resistor was just taking on way more current than it was intended to. And so I'm hoping that once I get this new part in, throw it in there, we'll be in a good place. And yeah, I guess I'll be back after that.